Okay, a big part about being successful in algebra is being able to recognize what everything means in an expression. So for example, 3 to the 4th. That whole thing is considered to be a power. The bottom number is the base. The number up top is the exponent. And together it's quite often referred to as a power. From before, I'm sure you remember, 3 to the 4th is 3 times 3 times 3 times 3, which is 4 factors of 3. You can then evaluate that expression. If it's numbers, you can evaluate and you'll get 81, the meaning of that question. That's what it actually equals. And don't forget you have a button in your calculator that will allow you to do, usually it's x to the y, or it can be y to the x. It can be a little roof. It kind of raises it up to a higher power. That is the button you will use if you want to evaluate an expression. So, something else to consider now. You can have a negative base. So negative 2 to the 3rd would be longhand negative 2 times negative 2 times negative 2. So a negative times a negative is a positive, and a positive times a negative is a negative. 2 times 2 times 2 is 8. Remember that any odd number of negative signs will be negative, and any even number will end up being positive. So negative 2 to the 4th will be one more factor. Negative 2 times negative 2 is a 4, times negative 2 is a negative 8, times negative 2 is positive 16. Now something to be careful, be very, very careful, like really careful. Negative 2 to the 3rd is not the same thing as this. You will notice that the negative sign is not in a bracket. What this question really means is negative 2 to the 3rd. It really means a negative 2 times 2 times 2, which is a negative 8, which gives you the same answer as the one above, but for the wrong reason. Because if the question had been negative 2 to the 4th, the answer would have been negative 16, because negative 2 to the 4th would be negative 2 times 2 times 2 times 2, so negative 16. So I'm suggesting you be very careful. If the negative sign is in a bracket, then that means the number, then base is negative, so you look for the rule that says an even exponent is going to end up being positive, and an odd exponent is going to be negative. Potential tricky type question. Not that I'm going to do that, just saying. So you have rules. The first rule is a power product rule. So if I had something like this, 2 to the 3rd times 2 to the 4th, and you're asked to simplify and write that as a single base only. The rule is you keep the base and you add your exponents. It's easy to understand when it's numbers because you can actually write it out and prove what the answer is. So you have 3 factors of 2, 4 factors of 2, 2 to the 3rd times 2 to the 4th is going to be 2 to the 7th, which you could then go on and evaluate. But that is written as a single exponent or a single base. And there are going to be questions quite quickly coming up when your base is going to be it's going to be a variable, a letter, and you will not be able to go on and evaluate. You'll have to leave it as a single base. So you should get used to that rule. And the rule is you keep the base never changes, 2 is a 2 is a 2, and you add your exponents. So you add your exponents. It doesn't matter If the exponents are negative, if the exponents are positive, you add them. Just don't break the rule. Say you had this question, 2 to the negative 3 times 2 to the 4th, you would keep the base, and you would add your exponents, and you would get negative 3 plus 4, and that would give you an answer of 2 to the 1, which of course is just 2. So you keep the base and you add your exponents. When you are dividing, different rule but similar rule. So for example, if you have 3 to the 5th divided by 3 to the 3rd, longhand, it would look like 5 factors of 3. So 5 factors of 3 divided by 3 factors of 3. You could look at it this way. You'd be left with 2 factors of 3, which of course is 9 if you want to evaluate, but the rule says you keep the base and you subtract your exponents. So 5 take away 3 is where the 2 came from. 3 squared. Now the rules don't change if the exponents and numbers don't work as nicely. So say 3 squared over 3 to the 4th. Longhand, 3 times 3 over 4 factors of 3. If I started to cancel and simplify it the old-fashioned way, you'd be left with only a 1 on top and 3 squared on the bottom. The rule says when you're dividing, you subtract your exponents. So 2 take away 4 is going to give you a negative 2. We know the answer is 1 over 9. We know the answer is 1 over 3 squared. This is an exponent rule that says, it's like a third rule taught in this example, but when you have a negative exponent, you can remove that negative exponent by bringing it to the bottom of a fraction and making it positive. And if you look at this example, 3 squared divided by 3 to the 4th became 3 to the negative 2. 3 to the negative 2 really has absolutely no meaning. Doesn't make a damn bit of sense really in terms of number values. But if you change it to the proper way to look at it, which is 1 over 9, if you evaluate that in your calculator at 3 to the negative 2, it's going to give you, as a decimal, 0.111, which is 1 over 9. So they're equal. And 9 times out of 10, be careful because the instructions are going to say to you, write your answer with positive exponents only. So if as a result of multiplying or dividing, you get a negative exponent, you're probably going to have to move it to the bottom of a fraction to clear it. So FYI. Another rule is called the exponent of an exponent rule. So I'm going to pick, I think I'll pick a smaller number. Don't get myself having to do too much mental math. Say you had something like 2 squared, and then it was cubed. That's a power of power rule. I want to do it out longhand because I'm not confident and know the rule. That's 2 squared times 2 squared times 2 squared. That's what cube means. Clearly, I now have it written as a power rule. The rule says keep the base, add the exponents, 2 to the 6th. So the rule then must be, and it is, if you have an exponent on the inside and an exponent on the outside, you have to multiply, not add. You add them when they're expanded like this. That's where you get the 6 from. But when it's in a power of a power rule, you can do a shorthand and not write it all out and just multiply them and get 2 to the 6. But you could then go on and evaluate if you wanted to later. So be careful when you get a question where you have more than one something inside the bracket. I'm going to throw some algebra in there to start getting us ready for that. So say you had something like, this is on your practice in your booklet, negative 4a and then squared. When in doubt, write it out. That means negative 4a times negative 4a. The rule says the exponent on the outside gets multiplied by all the exponents on the inside. Well, really, that's a 1, and that's a 1. So negative 4 times a negative 4 is going to give you a positive 16. And an a times an a is a to the 1 times a to the 1. The rule says keep the base and add the exponents. You're going to get 16a squared. And most students have no trouble to square the a, but sometimes they forget that you must also square the number as well, because there's actually 2 parts inside that bracket. A number, what we call a coefficient, and a variable. So these questions can compound and get more ugly looking. Say you had something like a times b over, say, 2, and that was cubed. You could write it out 3 times, or you could apply the rule that says a to the 1 cubed, a times a times a, multiply your exponents, 1 times 3 is 3, b times b times b, or 1 times 3 is 3, and 2 to the third, you would also have to do the 2 to the third as well, and you would get a to the third, b to the third over 8, if you're going to break it down to a final number. So be careful when there's an exponent outside your bracket that you apply that exponent to everything inside. Don't forget, if there's no exponent, the exponent is always going to be a 1. That's the rule. So if you had something like this, just to make it slightly more dirty and challenging, something like this. Say 49 x to the 5th y to the 3rd over 7 x squared. We'll do more of this in class together, but just because, get your brain warmed up. Something like this. So if you take this question kind of in parts, 49 over 7 you should be able to deal with. That's going to give you a 7, because that's what it is. If you look at this part by itself, x to the 5th divided by x to the 2nd, the rule says with the same base you keep the base and you subtract your exponents. X to the 3rd. If you look at the second bit, y to the 3rd over y squared, then again you'll keep the base and subtract the exponents and get y to the positive 1. So each of these questions we're going to do in algebra, which is going to build us towards being able to work with formulas later on, there are rules that all come together. When the bases are the same, when you multiply, you add the exponents. So multiply means add exponents. When you're dividing, you need to subtract the exponents, and when you have an exponent on the inside, an exponent on the outside, so like an exponent and an exponent, you got to multiply the exponents. Again, it's probably better if you go to your booklet for the proper terminology for that. Those are the three main rules, and all the questions can be done from those three rules. I'll give you one more before we depart. So say you had something, probably like let's call it a worst case scenario. Say you had x squared y to the third over x to the fifth y all to, say, a negative power, just to make it nasty. There's two ways you can approach this question. I'm going to recommend that you do inside the brackets first. So I see a division. I see x squared over x to the fifth. I see a subtraction. So I see x 2 take away 5. 2 take away 5 is a negative 3. I see a y on the top, a y on the bottom. It's a y to the 1. 3 take away 1 is y squared. And that whole thing is raised to a negative 2 exponent. So now I have the product of the powers. You need to multiply. So this number gets multiplied by that number, kind of like the old-fashioned FOIL, and that number gets multiplied by that one. So you're going to end up with negative 3 times a negative 2 is a positive 6, and a positive 2 times a negative 2 is a negative 4. That answer probably won't be as your choice, because the question is probably going to say, write all answers with without any negative exponents, or said another way, positive exponents only. So the rule for negative exponents, again, is to change them to a positive exponent by bringing them to the bottom of the fraction. So x to the sixth will stay as a numerator. The y to the negative fourth will go down and become y to the positive fourth. And that's going to be your answer. And this is just a little introduction to all these rules. One rule we didn't talk about was the rule of something to the 0. So I'll do that last one. Say you had this question. 4 to the 4th divided by 4 to the 4th. Expanded form, it's 4 times 4 times 4 fours, top and bottom. Something should be coming to your mind here for an answer. If the bottom and the top of a fraction are the same, you can cancel all those 4s. Going to end up with just a 1. The rule says when you divide, you subtract your exponents. Well, 4 take away 4 is a 0. Thus, there's a new rule. And that rule is any base, whether it's a positive base, a negative base, a fractional base, a decimal base, doesn't matter, any base to the power 0 will always simplify and become just a 1. You should lock that one in your arsenal and not forget it. Any base to the power 0 is going to equal a 1. You're also going to find some questions on your assignment about square roots and about scientific notation. Those are things that we've done before. I will caution you that a square root can be considered to be like a bracket. If you saw something like this. In a question, you would not do the square root of 100 minus the square root of 64. You would do what's under the root sign first. Because it's like a bracket, you would do 100 minus 64 and get 36. Then take the square root and get a 6. You would not do the square root of 100, which is 10, minus the square root of 64, which is 8. That would give you a 2. So if it's a root sign that has more than one thing in it, treat it like a bracket. Otherwise, evaluate as normal. Like, for example, if you had the root of 100 divided by the root of 64, it would be 10 over 8, which could reduce to 5 over 4. Enjoy your assignment and reading the booklet.